All right, guys, welcome to your very last video of the school year. I know it seems crazy. We are coming to an end of new material being taught. So for today, your very last lesson, we are looking at dividing square roots. So dividing has some different things with it. There's some of those crazy rules that a mathematician stated a long time ago and we still follow to this day. We'll kind of go over those. But let's start with the real basics, though, of dividing. So if you have like a big giant radical sign, so if you look down here at this example, you have this big tall square root of 3/4. And people are always like, I don't know what the square root of 3/4 is, but it's okay. A radical can be split, and I will always recommend that you split your radical to start. So meaning when I say split your radical, you want to do it as put the radical on top and put it on bottom. And then you can just simplify what you can, which the square root of 4 is just 2. So it's the square root of 3 over 2. So giant radical, split it, put it on top, put it on bottom, and then simplify what you can. All right, so for number 1, again, what's the square root of 16/49? I don't know. But if I split it first, square root of 16 over the square root of 49, well, I know the square root of 16 is 4, and the square root of 49 is 7. So what's the square root of 16/49? Well, it's 4/7. Okay, we can do radicals separately. Use it on the top and the bottom, and then go from there. All right, so number 2, always split first. So that's square root of 2 over the square root of 81. Square root of 2, that's not pretty, and I can't do a factor tree on it. So that's just going to stay the square root of 2. Square root of 81, that's just 9, because 9 times 9 is 81. And I am done. Number 3, we have the square root of 8 over the square root of 25. So we'll just deal with them separately. Square root of 8 is not pretty, but I can do a factor tree here. That's 2 and 4, 2 and 2. So I can pull out a pair of 2's, and I have a leftover 2. Okay, so I can deal with the top, clean that up. The bottom, the square root of 25, is 5. And I am done. Okay, so when we're looking at radicals, you always want to split them first. So radical top, radical bottom. And then just kind of treat it as 2 separate problems, right? So on the top, the square root of 8, I did my factor tree, I pulled out my pairs, and square root of 25 was just a pretty 5. Okay? Simplifying my fractions, 16 over 49 didn't simplify. 2 over 81 doesn't simplify. 8 over 25 doesn't simplify. And if you're someone going, all right, let's try a few more, some basic ones here. So the square root of 18 halves. What's 18 halves? That's just 9. They didn't simplify. So what's the square root of 9? That is just 3. Okay, so what I did there was I took a look at these 18 divided by 2. We actually want to go ahead and simplify that. Okay, so step 1, well, no, let's not talk steps. We want to always simplify. So yeah, okay, so step 1 would be to simplify your fraction. Step 2 is to split the radical and do factor trees. All right, so if I kind of go back to simplifies and you're not great with fractions, that's okay. Just grab your calculator, type it in. Type it in as a fraction and see if it simplifies. All right, so the next one, 168 over 7. Well, 168 over 7, if you type that in, it's just 24. So that's radical 24. Now notice it's still a radical because I didn't actually use the radical yet. Okay, so we don't want to get rid of it unless we use it. Using the radical means it's either a perfect square, like I used it on the last problem, right? I used it on the 9 to make it 3, so I used it and it's gone. This one I'm going to use it by doing a factor tree, which is 2 and 12, 2 and 6, 2 and 3. So a pair of 2's comes out, left over 2 and 3 goes in as a 6. So the square root of 168 over the square root of 7. Simplified my fraction, became the square root of 24. And then I used the radical by making a factor tree to turn that into the 2 times the square root of 6. All right, let's try number 6. We have the square root of 28 over the square root of 4. Well, 28 divided by 4 is just 7, so the square root of 7. And can I do a factor tree on 7? Nope, I'm done. Okay, so you always want to make sure you simplify your fractions first. So grab your calculator if you're not sure, type it in as a fraction and hit equals, and it should simplify it for you down to an actual simplified fraction. All right, the last part of dividing, we're going to get just a little bit into this. If we had more time, we would get more in depth with some harder problems, but we're going to keep it pretty simple, pretty basic for you. So a long time ago, some famous mathematician, I'm sure, came up with the rule that if there is a radical in the denominator, a radical in the bottom, it's considered not simplified. So if you look at the example, they had the square root of 4/3. 4/3 does not simplify, so they went ahead and split it, did their factor trees, whatever. Square root of 4 is 2, so we have 2 over the square root of 3. Since there's a radical in the bottom, it's considered not simplified. So what we have to do is called rationalize the denominator. You will learn in math, the harder something sounds, typically the easier it is, like in this case. So what you do, so here's the problem we just left off with radicals in the bottom, not simplified. Whatever that radical is, you will multiply top and bottom by that radical. So 2 times radical 3 is where I get 2 radical 3. Radical 3 times radical 3 is radical 9, and the square root of 9 is just 3. So we get 2 radical 3 over 3. These do not cancel, these 3's, because one's under a radical, like one's in jail, one's not. Okay, so they don't actually mix with each other. It's like an outside number and an inside number, right? They don't actually work together. All right, so let's take a look. Number 7. Again, we're only going to get into some very basic ones today. The directions say to simplify. I need to simplify because there's a radical on the bottom and we don't want to leave a radical on the bottom. So to get rid of that, we will multiply top and bottom by whatever that radical is. So on the top, 7 times radical 5 is 7 radical 5. One's an inside, one's an outside number. On the bottom, radical 5 times radical 5 is radical 25. And then I can simplify on the bottom because I know the square root of 25 is just 5. And I am done. Right? Remember, our goal is to get rid of that radical on the bottom, and I did. All right, so number 8. So I will multiply top and bottom by radical 6. So I get 6 radical 6 over the square root of 36. And then I know the square root of 36 is 6. Now, some people would stop there, but be careful. Now, we always need to look at inside numbers, outside numbers. Can I do anything with them? And I have an outside number of a 6 on the top and an outside number of 6 on the bottom. Those are going to cancel out. So it is just the square root of 6. All right, and number 9. Now, number 9, the only thing that's a problem is the radical 3 on the bottom. If you have a radical on the bottom, that is the problem, not the 5. Okay, so I multiply top and bottom by radical 3. So on the top, radical 10 times radical 3 is radical 30. On the bottom, I have a 5 as an outside number. Inside numbers, radical 3 and radical 3 make radical 9. Trying to simplify, if I do a factor tree, let's see, that's 3 and 10, 2 and 5. There's no pairs, so nothing comes out. It stays radical 30. On the bottom, I have 5, and then square root of 9 is 3. So 5 times 3 is just 15. I can't simplify those because, again, one's an inside and one's an outside number, right? One's under a radical, one's not under a radical. They do not mix together. All right, 3 more problems for us today. So on number 10, again, the problem is that radical on the bottom. So radical 15 needs to be multiplied top and bottom. So I get 5, and then my radicals 2 and 15 make radical 30. On the bottom, I get 2, And then my radical 15 times radical 15 is 225. We just looked at the factor tree on the last one of 30, which we know did not have any pairs. So that stays 5 radical 30. Here radical 225 is just 15. So 2 times 15 is 30. And then look at those outside numbers, 5 and 30. 5 and 30 can both be divided by 5. So 5 divided by 5 is 1. 30 divided by 5 is 6. So we get 1 radical 30 over 6. All right, so we need to make sure outside numbers, if we have them, that we make sure they are simplified. Again, you could grab your calculator. If you typed in 5 over 30, right, just 5 over 30 and hit equals, it would change that to 1 over 6, which is what I got going here, the 1 over 6. The radical 30 just stayed on top. All right, so number 11, 5 over 14. That does not simplify, so we will go ahead and split the radical, right? The steps I wrote, right? If it simplifies, do that, otherwise split it. Factor tree on 5, can't do anything. Factor tree on 14 is just 2 times 7, so I can't do any pairs. So that means I need to multiply top and bottom by radical 14 to get rid of that. So radical 5 times radical 14 is radical 70. On the bottom, 14 times 14, that's going to give me radical 196. All right, if I want to do factor tree, that's 7 and 10, 2 and 5, no pairs. So that stays radical 70. Radical 196, that is actually perfect. That is just 14. And we are done. All right, last problem, number 6. Or no, sorry, number 6, number 12. Radical 35 over 6. 35 over 6 does not simplify, so we will split that into radical 35 over radical 6. You want to try to simplify, right, with a factor tree. So 35 is just 5 times 7, no pairs. 6 is 2 times 3, no pairs. So if I don't get any pairs, then it doesn't do anything for me. So that means I need to multiply top and bottom by radical 6. So we'll have 35 times 6. That makes that radical 210. On the bottom becomes radical 36. Trying to clean this up, 210. I know that is 2 and 105. And that is 5 and 21. That's 3 and 7. I have a 2, a 3, a 5, and a 7. There are no pairs there. So actually, that does not simplify. And on the bottom, square root of 36, I know that's just 6. So we are done. So for looking back quickly at your steps, step 1 was to simplify your fraction. For those of you who like to kind of see this written out, sorry, my pen does not want to write. Simplify fraction. Step 2 is to split the radical and do factor trees. Looking for those pairs. Step 3 then is to rationalize denominator. Which is what we were doing, right? It's when you multiply top and bottom by whatever that radical is in the bottom. And then step 4 would be to simplify any, oh my goodness, it does not want to write, any outside numbers. Like we were simplifying over here in this one. This one had simplifying, right? The 5 and the 30 became 1 and 6. So that's what I mean by simplify outside numbers. All right, that is it for today, guys. That was your last lesson. So go ahead and practice the homework, and then you have 1 quizzes over this, 75% or higher, and you are done with this year of math. So hopefully that went well. If you have questions, please reach out, follow some step-by-steps, and don't feel bad to ask me for help, okay? That's what I'm here for. All right, guys, thanks so much.